Hello and welcome to an instalment of Mantis Hacks. In this instalment I'm actually going to be taking a little look at this second-hand Lulzbot Mini that I recently acquired. And what I'm going to be looking to doing is making it quieter. So this is a second-hand Lulzbot Mini that I've picked up recently, and I've been using it for a few days now, but I had noticed it was quite noisy, especially in comparison to my TAS 5 and TAS 6. What I'm going to do effectively is look at changing the fan in the power supply unit on the side here, and also putting some dampers on the stepper motor units. What I'm going to do first is I've got this little app running here which is basically telling me decibels noise. It's not been calibrated, but it'll give me a relative difference before and after I install the new fan and the stepper motor mounts. So when you switch on any motors or the heater or anything, then the fan kicks in to start cooling the electronics inside of the control box. So let's take a look at that. Okay, so I just set the bed temperature to 30 degrees and you can probably hear the fan kicking already. And it's now up to about 53 dB. Yeah, it's hovering around 52, 53 dB on this meter. So it's quite a significant noise just from the fan alone. I've gone for a quieter 24 volt fan here. Now obviously this isn't going to push as much air through the system as this one is. So what I am going to need to do is switch this out and then be careful and do some test prints and make sure the system isn't going to overheat. But I'm going to do that and give it a go. Alright, so let's switch it off. Unplug the USB. I'm going to take the spool off. Spin it around and just pull the IEC lead out the back. There we are, disconnected. And just to make sure everything's discharged inside, I'm just going to turn it back on. Yep. Okay, so now we're ready to start taking it apart. And it looks to me like there's some screws up the front here, and there's some screws coming down the back. Okay, so I'm going to take these ones out and see if this side panel comes off first. Here we are inside of it. And the fan is mounted just here. See what it says on it. It's a 24 volt fan at 0.14 amps. Let's just look at the one I've got here. So this is 24 volts at 0.04 amps, so it's a much lower wattage fan, this one. And just check I've got the right size. Yeah, it looks like I have. This fan is a little bit shallower actually. This is about a 15mm and this is about a 20mm fan, so hopefully it's not going to interfere with anything. We'll have to have a look. And it looks like the fan is plugged into the motherboard down here. Yeah, there's a little plug in there. Now this is a 3-wire fan. I don't obviously need to use this third wire, it's just the feedback of the fan speed, so I can get rid of that. And then the other 2 wires obviously need to go where this one is. I don't have a plug the same as that, so I'm probably just going to do this a real easy way, which is to use a terminal block to just join these back in, and I'll snip this one off here somewhere. To get the old fan out, it's got nylocks on the back of it here. Now one thing I have thought already, being that this one is deeper, these bolts probably aren't going to be long enough for this new fan. So I might have to do something different, or maybe put the nuts in between the 2 layers rather than going all the way through. I'll see. Alright, so just to make this easier to work on, the only thing that connects these 2 parts together is the fan cable, which I've already disconnected, and this power cable here, which I just noticed is on a little plug. So now that's nice and easy to work on in with one piece. So there's the old fan taken out, and just noticing the direction of airflow, which is going that way, so it's pulling air in. So we need to make sure we do the same thing with the new fan. Now let's see if these bolts are going to be long enough. I don't think they will. No, they won't. So I'll have to try and get the nut in between the 2 slices here. In this bit, it could be a little bit tricky, this. Let's have a go. I don't have any shorter screws here or any longer ones, so I'm just going to have to try and use these for now. That's the new fan in place and just wired by that terminal block, so if I need to switch back to the old fan, it's fairly simple to go back again. Like I said, I really need to test this because being a quiet fan, it's basically a much lower airflow. That's how this one gets the noise level down. So it might not be the best idea to do this because, of course, the internals might overheat and things might start going wrong. Hopefully it'll go back together as easy as it came apart. There it is back together, so I'll power it back up again now, and fingers crossed. Let's just get the bed switched on a minute. There you go, the bed's on. The fan is running. And we're at 27 dB, so what was I before? I think 52 dB, down to 27. So yeah, it's very quiet. However, I can feel there really isn't masses of airflow now. So whether this is going to be pack enough punch or not, I'm really not sure. I'm going to have to fire it up and give it let it run on a print for a while and see how warm it gets and see if anything starts to go wrong. Okay, so I've been running the printer now for a little while with the new cooling fan installed, and I've done a couple of 6-hour, 7-hour prints, some longer, and it seems perfectly okay, so I think I'm happy with that. So the next step is going to be installing these little anti-vibration dampers. They're little cork washers effectively, and I'm going to try these on the X and Y axis to start with. I don't think I need to do the Z axis because that only really makes a noise when it's calibrating at the start of the print, and it makes a very small amount of noise when it's moving up throughout the print. So what I'm going to do first is actually start a print off and just take some measurements and see what we've got to start with, and then I'll go about fitting the dampers. So I'm getting a reading of about 56-58 dB next to the printer, and if I bring it up to the camera a minute, which is about a metre away from the printer, yeah, it's about 53 to 55 dB. And about 58 when it's closer. So I've stopped the print. I'm going to disconnect the spool, power the printer down and get it ready to install these washers. I haven't actually looked up how I should do this, but what I'm going to do is I've just released some tension on the Y-axis belt here, just by undoing one of the clamps. They're fairly easy to tension back up again. And so now I'm not too tight on the stepper motor here. And I'm going to drop these screws out so I can release the stepper motor. And I might have to take a little bit more tension off the belt, and then maybe move the spline up the tooth pulley up the stepper motor a little bit so it realigns with the belt nicely afterwards. Because obviously this is going to add some depth to it. Okay, that's the stepper motor removed. I'm just going to put the washer over the top and reconnect it. There's some very short screws on the stepper motor, so I'm probably going to have to find some longer ones because I'm not sure they'll go through the extra thickness of this washer. I'll give it a go. I should move this tooth pulley by that thickness further this way along the shaft. The bolts were just about long enough to bite, and of course the washer is compressible, so it does pull up a bit. So they kind of work. Maybe would have done with some better with some slightly longer bolts. So the next thing is I had to loosen the belt off a bit to get it back round. And what I did do before I disconnected the belt was I just felt the tension with my finger, so I know roughly how tight to take it back to again. And then to tighten the belt up, I'm just the belt just protrudes through the clamp here. I've got one clamp loosened off, and so I can just grab one end of the belt, and I can just kind of wind the pliers to pull it through the belt clamp until I get it to the tension that I want it again, and then tighten up the clamp. I've just finished installing the Y-axis damper, and I'm going to test that first just to see if it is worth going ahead and trying the X-axis as well. My first thoughts are that it hasn't really changed much at all. It does sound different. I'm not just not sure whether it's that much quieter. Anyway, I'll run the same test print and I'll test it on the meter and see how it's performing. According to that, it's louder. So I'd say that was a fail. So despite not having much luck with the Y-axis isolator, I went ahead anyway and installed them on the other axes. So what I did is I've put these on the X-axis, obviously the Y-axis to start with, and also the two Z-axis motors. I don't think they've made massive difference, to be honest. I think the X-axis got a little bit quieter, but the Y and the Z, which is the noisiest axis, hasn't really made much of a change. To do the X-axis actually is not too bad, because you just bring the carriage up until it lines up with this gap up here in the back of the printer, and then you can get to the back screws on the X-axis. And the Z-axis is, again, they were pretty easy. A simple way to do it is just drop the screws out on the Z-axis. Just cut through one side of this so it just slots around the motor shaft, and it's really easy to get on. Like I said, it didn't really make much difference. I do have another version of the damper coming for the Y-axis, which is supposed to be much better. I will try that when it turns up. So the last thing I can do is add this case, which is a printed solid case from Lulzbot store. Obviously still got quite some big holes in it, so it's not going to do masses for the noise. I think it's more of a safety case than anything. I've installed most of it already. The back piece is on, the front is just down here. Let's just get the sound meter fired up. Yeah, about 60 dB here. Let's have a little look next to the camera. Okay, it's about 55 dB. Now let's put the front of the case on and see what it's like with that in place. Yeah, not masses of different. There's a little bit maybe, but the thing is with the case is it can act like a bit of a sound box if you're not careful, and also can rattle a bit. If you've got a really aggressive moves on the head, the case tends to rattle, so maybe it'd be benefit from some felt or something just to stop it from moving about. Okay, so I have the final thing I want to try, which is this slightly nicer stepper motor isolation. It's two pieces of metal joined together with a rubber isolation washer there. So the isolation should be much better on this, because the screws don't transmit any noise through the where they would do through the cork isolator. So what I'll do is I'll fire it up as it is now. Currently it has the cork isolator on the Y-axis, but I'll take a meter reading again with a print going. I'll then fit this and do the same meter reading and see if there's any difference. So I'm just going to disconnect the belt, one of the belt tensioners here, and let some belt slack through. Now I'm going to remove the 4 screws that hold the stepper motor in place. Take the belt off. There's the cork isolator removed. Right, so the new isolator has 2 sides to it. One has threaded holes and the other doesn't. So the stepper has threaded holes in it, so I'm going to put screws down through these ones into the stepper, and then through the plate here into the threaded holes on the other side of the mount. This isolation mount is a lot thicker than the cork one, so I'm probably going to have to move the toothed pulley up the shaft on the stepper motor slightly to account for the extra thickness of this. So I'm going to do that first before I take it any further. Alright, that's the isolation washer fitted. That was pretty easy. Now I just need to get the belt back over and tension the belt up and make sure it's sitting at the right height on this toothed pulley here. Right, so that's the nicer damper fitted, and I've just been using the jog controls to move the table around. That damper has made the Y actually quieter than the X-axis now. So I'm going to heat the bed up and start that print off again and take some measurements. I can't believe how much difference that has made. It really is almost whisper quiet. A quick summary of what I did with my Lulzbot Mini to try and make it quieter. First of all, I changed out the cooling fan in the electronics, and that definitely seemed to make a difference, so well worth doing. Of course, that does depend on ambient temperature, and the ambient temperature in my flat is about 21 degrees. So if the ambient temperature does go up quite high, then you might want to take care if you are going to fit a quieter fan, because they don't shift as much air. The second thing I did was to try and add these cork noise dampers to the steppers on the Y, X and Z axes. They really didn't have much of a change on the Y axis, in fact no change at all, I would have said. The X may be some difference and the Z may be a tiny bit of difference, but not much, not really worth doing. I then added the case, which made a little bit of difference to the noise, but really, you know, the case needs a little bit of improvement. It needs maybe some felt dampers where it fits to stop it from vibrating a little bit. And then the last thing I did is I swapped the Y-axis damper that I had installed, one of these cork ones, with one of the 2-part metal plate with a rubber shim in between. And that really has made the biggest difference of all on the upgrades that I've done. So ultimately I would recommend the Y-axis damper, the really good type, not the cork ones, and the electronics fan enclosure. I would also upgrade that if you want to make your Mini quieter. Do bear in mind that making these modifications to your Mini may void your warranty. Don't forget to check the description for links to parts that I used and further information on these modifications, including a link to Lulzbot's own tutorial on the Y-axis upgrade.